Hello again, and to further continue, coming to the next lesson, adoption of automotive electrical systems for onboard diagnostics in electric vehicles. We are going to see how the automotive electrical systems are adopted or aligned to onboard diagnostics in electric vehicles. Now, in the previous chapter, we spoke about IC engines. Now, here we are going to talk about electric vehicles. Now, electric vehicles have refined or redefined the architecture of automotive electrical systems, shifting the focus from combustion-related diagnostics to battery-centric high voltage and software-driven monitoring. Here's a comprehensive look at how onboard diagnostic systems evolve and adopt in electric vehicles. Now, first is shift in diagnostic priorities. How are the diagnostic priorities shifted as the industry is making a transition from IC engine vehicles to electric vehicles? Understand this sentence very carefully. Unlike internal combustion engine vehicles, EVs eliminate components like fuel injectors, spark plugs, exhaust systems, and instead diagnostic focus on battery health, performance, electric motor, inverter efficiency. Now talking about and also the charging system integrity, thermal management, high voltage safety. Now these are the various verticals in the electric vehicle that need to be monitored or that need to be kept under vigilance. Now this shift demands more data intensified and predictive diagnostic approach. Now talking about the battery management system, the battery management system is art of EV diagnostic responsible for monitoring state of charge and state of health. Now coming to the balancing cell voltages across the battery pack, detecting thermal anomalies and voltage irregularities, logging charging cycles and degradation patterns and stress indicators. Now talking about the real-time battery data is often transmitted to cloud where machine learning algorithms analyze trends to optimize performance and extend battery life. Okay, so this battery management system is like the heart of the electric vehicle, so naturally this has to be brought under diagnostics. Next important system is high voltage system monitoring. All right, so how do we monitor the high voltage systems? The electric vehicles operate on voltages ranging from 400 volts to 800 volts. So diagnostics must ensure insulation integrity to prevent electrical hazards. Next is current leakage detection, connector and cable health, safe operation of DC-DC converters and DC-DC converters and inverters. Coming to the next is specialized sensors and diagnostic protocols are used to monitor these systems safely. Now, next is thermal management diagnostics. EVs rely heavily on thermal regulation to maintain battery and motor efficiency, and sensors track coolant flow, temperature gradients, and heat exchanger performance. Diagnostics detect overheating, pump failures, or coolant leaks. And AI models predict thermal stress based on driving behavior and ambient conditions. Okay. Now, when it comes to charging system diagnostics, charging related diagnostics include communication with charging stations via OCPP protocols. Now, a small homework to all of you. Understand what is this OCPP, search in internet and find out what this OCPP means. Okay, you will find this very interesting. Now, coming to the monitoring charging speed, efficiency and voltage stability. Next is detecting connector faults. This is a very important fault that need to be diagnosed and monitored in a very proactive manner because this can lead to the switching of the entire vehicle. So detecting the connector faults, overcurrent or incomplete sessions, logging charging history for warranty and performance analysis. All right, so these are all coming under purview of charging system diagnostics. Now, coming to the cloud connectivity and remote diagnostic. Now, this is also an important vertical which is becoming more and more rampant in modern vehicles. Now, EVs are deeply integrated with cloud platforms and real-time data transmission enables remote fault detection. Over-the-air updates fix software bugs and enhance the features. Fleet operators use dashboards to monitor vehicle health and optimize usage. Okay, so these are the various areas or faults that need to be monitored as far as the cloud platform is concerned. Now coming to the diagnostic interfaces and tools, EVs may still use OBD-II ports but rely on the OEM specific interfaces. Okay, so even electric vehicles OBD-II ports under the dashboard are prevalent, but more and more they are relying on the OEM specific interfaces. And when it comes to diagnostic tools, must support EV specific protocols and high voltage safety standards. Some EVs offer mobile apps for users to monitor battery health and driving efficiency. So some of the modern electrical vehicles, it may be MG Windsor or MG Comet or Tata Nexon. Some of the modern vehicles, they are offering their own personalized, customized mobile apps through which they can monitor the battery health and driving efficiency. Now talking about the challenges and innovations, the first challenge is lack of standardization. Now this is the biggest problem which electric vehicle industry is facing: lack of standardization. Now customized apps and applications may have their own advantages, but the biggest disadvantage is lack of standardization. So when it comes to lack of standardization, the innovation or the solution is development of EV specific OBD protocols. Now in IC engine vehicles, OBD protocols is a very what you call matured knowledge and technology. So likewise, it's about time. Even in EVs, OBD protocols are brought up to a matured standardized procedure. Next is high voltage safety, insulation monitoring and fault isolation. Now this is the innovation that must come into picture to provide a solution to this challenge, which is high voltage safety. Now when it comes to battery degradation, cloud-based predictive analysis, limited aftermarket access, secure application program interfaces, and diagnostic platforms. Okay, so these are the challenges and innovations. And in conclusion, a smarter, safer diagnostic ecosystem. Okay, once you standardize the electrical vehicle OBD, a smarter, safer diagnostic ecosystem will naturally be right in the horizon. So in the electric vehicles, onboard diagnostics evolved from mechanical fault detection to intelligent software-driven systems that prioritize battery, longevity, safety, and energy efficiency. With cloud integration and artificial intelligence, diagnostics are no longer just reactive. They are predictive, proactive, and personalized. Okay, in the coming chapters, I will be talking about one very state-of-art OBD system called prognostics, and you will understand what level of proactivity can be achieved with the help of prognostics. Okay, but for now, you understand that in the electric vehicles, onboard diagnostics are highly predictive and proactive. They are not reactive anymore. Thank you. Thank you for listening.